All right, guys, so this problem is going to deal with a variation problem. Now, sometimes variation problems, I know for me, were a little bit confusing, but the best way to think about them is in reference of your paychecks or pumping gas. Variation problems normally deal with some kind of constant of variation, something that's going to stay the same, such as how much you make per hour. The amount that you make per hour, let's just say $10 an hour, is going to make a difference in, hey, if I work 8 hours, if I work 20 hours, how much is my paycheck going to be? Or how much each gallon of gas costs is going to make a difference on how much I'm going to have to pay when I fill up my tank. So taking in those factors, those constants of variations, that's what these variation problems typically address. They're pertaining to some kind of problem, some kind of situation where we're dealing with some kind of constant of variation, and that's going to change depending on what kind of problem you're talking about. But we have some constant that's going to stay the same within that problem, and we can use that to calculate all sorts of different things, right? If we made $10 an hour and that was going to stay the same, regardless, let's say if I told you, hey, you worked 15 hours, you worked 30, you worked 45, you would be able to calculate for me all those different scenarios on how much you should get paid that week, right? So that same thing applies to these kind of problems here. Though we do need to be aware when it comes to variation problems that there's a few different kinds of variation. There's direct variation, there's inverse variation, there's variation as a square, and just different things like that. So depending on what kind of situation you have, that's going to play a big part because we have a few different formulas depending on what situation we have. So reading through this problem here, if A varies directly as the square of B, and A is equal to 3 when B is 8, let's find when find A when B is equal to 7 here. So this one here, we're talking about A varies directly as the square of B. So let me show you the formula that we're going to be dealing with when it comes to this kind of problem. So the typical formula that relates to this kind of example here is y is equal to kx to the nth power. So this is the one where it talks about direct variation as a square or as a power of something. So this is very important. The only difference here is, we typically use y equals kx when it comes to our equations here. Instead, they're talking about a's and b's. A varies directly, the square of b, and so forth. So the only difference here is instead of a y, they're talking about an a. So a equals kb to the nth power, related to just the variables that they're expressing here. So a, using this a here, the square of b, and so forth. So we're just going to take that, the typical equation here, and change it up so it matches up with the variables they're talking about in this problem here. Now it's a matter of plugging and chugging and calculating for this particular problem here. So once we know what formula we need to use, and that's just a matter of grabbing your book or being familiar with variation problems enough to where you're able to just read the question and know which equation to pull. Otherwise, what we need to do for most variation problems, the first thing that we typically need to do is find k. We need to calculate what is our k, what is our constant of variation. So if I need to figure out what k is, I need to plug into these other components so I know what k is. So that's going to mean, before we go to this last part of the problem, find a when b is 7. So that's going to be our second part of this problem here. What we're going to do is we're going to take this given information up here and we're going to plug it into our equation so that we can find what k is. And once we know what k is, then we're going to take that to solve our given problem. So this first sentence, a varies directly as the square of b, that's what gives us this, or that's what tells us to use this specific formula. And even further there, it says the square of b. So think about, what is a square? If you're squaring something, that's actually a power of 2. Had it said cubed, we would have said 3. To the 4th power, we would have put in a 4, and so forth. So this is really the equation we're going to use. And it says if A is 3, so I'm going to plug in 3 for A. And then it says when B is 8. So here I'm going to plug in an 8 for B. And let's calculate this thing. So if we're going to calculate this thing, let's see, the first thing we need to take care of is our exponent. So there we have 8 squared, so 8 times 8 is 64. So in order to solve for K, all we got to do is divide by 64 on both sides. So we get that K is equal to, so let's see, we're going to get a pretty small decimal here. And to help me do this calculation here, I hope y'all don't mind, I'm going to pull out my handy dandy calculator and say 3 divided by 64. I'm getting 0.047. I'll round to 3 decimal places here. Hopefully, whatever problem you happen to be working on, it should let you know or give you an idea about how far to round for these specific problems. I'm going to round to 3 decimal places. So by plugging in here, I found that K is equal to 0.047. Now what I'm going to do is I'm going to take that same equation and I'm going to take in K, what I solved for, plug it into my equation here, 0.047. And now I'm going to look at my second piece of information and I'm going to calculate that. It says to find A when B is 7. So I'm going to plug in K, our constant that we just solved for, right? And now we're going to plug in B, what they gave us, so that we can calculate this and figure out what A is going to be. So again, I'm going to grab my calculator here. I hope y'all don't mind. So first off, taking care of our exponent, 7 squared. 7 times 7 is 49. And if I take 49 times 0.047, I'm getting 2.303. Now, we weren't really told what this specific problem is pertaining to, so I don't know what this 2.303 represents, but they asked us to solve for it, so here you go. So first off, making sure that you have or that you pull the correct formula, and that's just going to depend on the wording that they give you. Always solve for K first, and then use that K to plug in with your other given information to solve for what they specifically are asking you.